Thank you so much, Roman, and thank you so much for putting so much pressure on me now. I'm just delighted to be introduced by this smart guy, by the way. And of course, thank you so much for joining, guys. I'm nothing but just excited to welcome all of you to this session here. Now, this session, as already mentioned, will be all about exploratory testing. And in order to safely dive into that topic, let me start with a short story, a story about myself. So in August this year, I have enjoyed 4 weeks of holidays. And guys, I tell you, it was just great. Now, whenever I go on holidays, I define a theme. That means a topic or a set of topics I'll focus on during my holidays. And for this year's holidays, I have selected the theme Creative Thinking. Now, the reason why I even came up with the topic was that I've read quite a lot about this guy here in the last couple of months. His name is Erwin Schrödinger, and he's one of the founding fathers of quantum mechanics. And by the way, he's the man behind Schrödinger's cat. Now, in one of his numerous letters he wrote to his friend and to the genius Albert Einstein, he once said, "The task is not so much to see what no one has yet seen, but to think what no one has yet thought about." And this statement immediately blew my mind. I just thought, how can it be? How can I make myself able to think about something nobody has ever thought about? So I did what everybody would have done. I asked Google. So I searched for Think Different. And this was obviously a bad choice because all the search results I received were all about this company. So I had to change direction. So I went back to Google and searched for Think from Different Perspectives. And in the very first search results, Google then suggested this book to me. It's called Lateral Thinking, written by the Maltesian thinking guru and author Edward de Bono. And in this book, Edward de Bono makes a compelling statement. He says, you cannot dig a hole in a different place by just digging the same hole deeper. Now, what the heck does that even mean? Well, now imagine there is some problem floating around, and the problem approaches you. So you need to solve the problem. You are asked to solve the problem. So what do? You apply all the problem-solving techniques you have learned so far from your friends, from your parents, from your colleagues to get the problem solved. But now imagine none of these problem-solving techniques works out. And so then it doesn't really matter if you apply all those techniques over and over and over again, because none of these techniques will solve the problem. So this then implies that you have to solve the problem from a different viewpoint. You have to attack the problem from a different perspective. And that is what lateral thinking in really rough terms is about. It's just a collection of different problem-solving techniques to solve problems in a more creative way. Now, to be more concrete, let's do a simple example. I hope everybody of you knows this guy here. It's a Mr. Roger Federer. And as already suggested by this picture, here we are obviously at Wimbledon. And now imagine there are 128 players playing a singles tournament in Wimbledon based on an elimination basis. That means based on a traditional knockout system. So given that setup, the question is now, how many matches must be played to determine the winner? And guys, I'll bet everything I have that everybody of you, including me, would have solved the problem in the following way. You would say, well, in round number 1, there are 128 players. So I have to play 64 matches. So in the next round, 64 players will remain, and so I have to play 32 matches, and so on and so forth, until you reach the final, where just 2 players fight for the title and play for the Wimbledon title. So if you then add up all those matches, you will see that you have to play 127 matches to determine the winner. Now, that way of solving the problem, or that way of even thinking about the problem, is called vertical thinking. where the solution is derived by pure logical deduction. And now the big question is there any other way? Is there a more efficient way to get the problem solved? And indeed there is. And that is exactly where lateral thinking gets into the game. Now, one technique in lateral thinking is called factorization, where you break the problem down into smaller chunks. So, for example, you focus on the tournament, the knockout system, or the players, and you can break those chunks down further down, for example, the players, to the losers and the winners. Now, we already focused on the winners, so why not just focusing on the losers? So what we know is that one player wins the tournament. So that there have to be 127 players who must lose. But now it comes. Each loser just loses once. And for that reason, 127 matches must be played. So that's a completely different way to solve that problem. It's a creative way to solve the problem. And please bear in mind that creativity is nothing more than just the capacity to challenge the existing order of things. It's just the capacity to break out of your established thinking patterns. And that is exactly what exploratory testing is about, at least from my naive perspective. And that is exactly what exploratory testing distinguishes itself from any formal testing technique, especially when we do test case design, where requirements, and so test cases, are derived in a methodical and structured way by pure logical deduction. And if the way we think when we do exploratory testing wouldn't be the difference, would not make the difference to formal testing, what would it be at all? And we see it day in and we see it day out, that the way of thinking differentiates these two testing disciplines. Because there are so many issues we are about to find, so many different types of issues. And we see it every single day, that some of them will be found by exploratory testing techniques, and some of them will be found by formal testing techniques. But not all of them will be found by either one or the other. So the bottom line here is that exploratory testing and formal testing, including automation, they're just boson buddies. I always say they're more than friends, but less than lovers. Because, alone with just one of these methods, we can do so little, but together with both of them, we can do so much. And for that simple reason, discovery in general and discovery of these issues in all of our testing endeavors, in each and every project we do, consists of looking at the same thing as everyone else and thinking something different. Now, the good news here is that we regard something as properly tested when it is being checked by efficient formal test automation based on a solid test case design, and when it has been explored by the richness of intellect of human beings. So this is at least our Agile equation of motion, and the reason why we pay so much attention to this testing discipline in all of our projects. And that's, by the way, the definition of done when it comes to product development. Now, the good news here is that lateral thinking, and so exploratory testing, it's not a talent. So you don't need to be a smart person, or you don't need to have a bright mind to do that. No, it's a skill, and it's a skill that can be learned. So let's see how we translate the approach of exploratory testing into practice. Because knowledge that is not put into practice is like food that is not digested. So let's see how we digest the food. Let's see how we translate exploratory testing into reality. Let's have a look at our technique to do that. Now, our technique is composed of 5 components. The first one is session-based testing. And what session-based testing does, it just takes exploratory testing and puts it into a straitjacket. So it puts all the imagination which comes along with exploratory testing into that straitjacket. And by imagination, I just mean the ability to form new testing ideas. And now you might say, well, that's incredibly bad, right? And indeed it is, but it really depends on how tight you tie up that straitjacket. But we do that in order to make exploratory testing structured. Why do we do that? In order to allow it for larger scale implementations. Because the challenge is not to do that for 1, 2, or 3 teams. The challenge is to do that for 30, 40, or even 50 teams, or even more in a truly agile enterprise. And so you need to have some structure at hand to do that properly. Why? Because only if you have structure at hand, you can perform exploratory testing consistently. And why the heck should you do that? In order to measure its success at the end of the day. And it's the single reason why we go for session-based testing to unfold exploratory testing into practice. Now, the core object of session-based testing is the session. And the session is nothing more than a chartered, reviewable, and uninterrupted unit of testing effort. And this testing effort usually is time-boxed, let's say between 30 and 90 minutes or so. And the sole reason why we time-box that session is not just for the sake of time-boxing a session, is to curb our perfectionist tendencies during testing. Is to avoid that we as testers overcommit to a testing task, which usually happens when there is no deadline. And the core object of the session itself is called the session charter. And the charter is just a mission statement. It just describes precisely and concisely what you are looking for. Now, the big question is now, how do we find the scope of such a session? How do we mark the territory of a session? How do we set its boundaries? And in order to do that, we apply a traditional requirements-based approach. And I know, guys, even mentioning the term requirements in an agile world on a continuous testing company, it's so bad, right? It's so bad. But for me, a requirement is nothing more than just a service we provide to our end users through our products so that these end users can achieve their goals, whatever they are. And I don't care if you express those requirements as a system use case, a business use case, a feature, a user story, an epic, a theme, whatever you like, take whatever you like, it still will remain a service. And we make use of these services to limit the scope. Now, why do we do that? Well, in order to make it manageable. Especially for unskilled testers, because the sheer functional and non-functional spectrum of our systems is often so attractive that you get so easily lost in details. So stay within the scope. Now that's how we limit the scope. So now we have seen how we time-box the session, how we limit the scope, but now the big question is, what the heck should we even do within that specific amount of time? That means, what are our goals? What are we about to find there? And in order to set concrete goals, we apply an approach which is known as tour-based testing. And the testing tour is not just taking a test case and calling it a tour, it's the entire metaphor. It's an exploration around a theme. And there are many different types of schools of tour testing out there. And also different types of tours out there. The one I like most is the one proposed by James Whittaker in his book, Exploratory Software Testing. And in this book, he describes various different tours, like the supermodel tour, the museum tour, the FedEx tour, the couch potato tour, the money tour, and so on and so forth. And what these tours are doing for you, they inspire you to set a crystal clear goal in order to provide a clear focus to your session, to focus on a very specific aspect. Like the FedEx tour, here the only goal you have is to make sure that you have a consistent data flow in your application. Or in a supermodel tour, you think superficially. You never go beyond skin deep, right? Like the supermodels do. And now let me give you the reason why this is important. An example, Google Maps, a few years back. And now imagine you want to go from Oslo to Stockholm. Now, what Google Maps suggested at this point in time was a route something like this. I hope you can see that. And this was presented at an internal Google conference. And they just said, well, they just hate the Norwegians because whenever they want to go to another place, they have to go through the United Kingdom. So that's the way how they justified that bug here. But the quick question is, how the heck do we find this sort of bugs? I mean, you can get lucky to find this sort of bugs, but who wants to be lucky in his career? I don't want to be lucky, right? And maybe there, in manual testing, there's some random neuron in your brain firing and giving you the insights to find these sort of bugs. But we can't just hire genius testers with Jedi instincts. And not everybody has those instincts to find this sort of bug. So how do we find this sort of bugs? Well, first of all, it takes understanding about your application from a business and from a technical perspective. In that particular case, it takes the understanding that there can be black spots or dark spots in the mapping data. There can be areas where the mapping data is just incomplete. Or there can be areas where old mapping data is connected to new mapping data, and so on and so forth. And it takes preparation to gain that knowledge. But if you then take that knowledge, you will find these sort of bugs not in units of days, not in units of hours. You will find them almost instantly. And you won't find those issues if you focus on 10 different things at the same time. And you won't find those issues if you focus on 3 different things at the same time. So you've got to focus on very specific issues. And that is what tool-based testing does for you. So all in all, I think we need to agree upon the fact that testing is just blind without a mind, because there is no brain in the loop per se when it comes to formal testing. And that's the reason why we have to go for exploratory testing. Now, we do all that in order to maximize one single quantity. It's the quality. It's the quality of our software products, or to be more precise, it's quality at an ever-increasing speed. Now, I think everybody perfectly knows what speed means, but what the heck does quality mean? Well, for me, quality is just the degree of excellence of something. The question here is, who measures this degree of excellence? Well, it's measured by someone. And so Jerry Weinberg concluded that quality, in really rough terms, is just some value to some person. Now, this then implies that quality is inherently subjective. And the result of this, different stakeholders will perceive one and the same product as having different levels of qualities. Now, what's the implication for testing? Well, this all means for us that we as testers must look for different things for different stakeholders, which essentially means we must diversify testing. And so this leads us to element number 4 of our technique to exploratory testing, which we call polychrome testing. Now, polychrome just means doing an art of work in different colors. And that is exactly what we do when it comes to exploratory testing. We explore the product from different viewpoints to maximize the diversity in our approach to testing. Now, in order to do that, we apply an approach or a concept which is known as, I'm so sorry. In order to do that, we apply a concept which is known as the 6 thinking hats. It's a concept, an idea, again born by Edward de Bono. And this concept is being used for more than 20 years already to solve business issues in general. So it basically has nothing to do with testing. And the core components of that concept are the so-called 6 thinking hats. They're literally hats. And each hat, as displayed here, has a certain color associated with it. And each color stands for a certain viewpoint, a certain thinking direction. So when we run an exploratory testing session, we invite multiple testers and each tester takes a different hat in order to diversify our approach to testing. So we don't just go for critical thinking. We also go for creative thinking, positive thinking, emotional thinking, or factual thinking in order to maximize diversity. And last but not least, we also apply what we call a scenario-based approach. And this simply means that each and every test idea is documented and captured and put into a so-called exploratory scenario. Why do we do that? Well, in order to make it reviewable at the end of the day. Why do we do that? Well, in order to measure its success and to define the next test properly. Now, having all that said, let me conclude with one single statement. So when somebody would ask me what exploratory testing really means in one single sentence, I would say that exploratory testing is any testing that machines can't yet do. Because of the simple reason that exploratory testing is definitely not so much a thing you do, it's much more a way you think, guys. Thank you so much.